We're on page 26 of our linear functions booklet. If you have any questions about this page, please write them down at the top of your booklet. F of x equals negative x, where x is less than 0, and x when x is greater than or equal to 0. That's the piecewise function representation of the absolute value function. One thing to note, the equal to sign could always be on either piece of this. So you could have a line under here instead of this one. So let's look at this example. F of x equals negative 2 absolute value of x minus 1, close absolute value, plus 4. This equation is in standard form where h equals 1 and k equals 4. Your h is right here, your k is right here. H is always the opposite of what's inside, and k is always the same thing. So if we look at this graph, find the y-intercept. That is where it crosses the y-axis. There's only one. It's right here. That is the y-intercept. Let's label this point. Our coordinate point is 0, 1, 2. 2. So our x is 0. We don't go left or right. And our y is 2. We go up 2. So our y-intercept is 0, 2. So that means that b equals 2. If you're looking at a linear function. Absolute value functions are really just two linear functions together in a piecewise. Now for x-intercepts, in this case we're going to have 2. That's where it crosses the x-axis. So let's find them. Here's one, and here's the other one. So for our x-intercepts, go ahead and write out the coordinate points for these. Okay, this one is -1, 0. And this one is 1, 2, 3, 3, 0. So our x-intercepts are -1, 0, and 3, 0. So that means our zeros are x equals -1 and x equals 3. Those are our roots. So basically for our roots, 0 solutions, those all mean the same thing. We look at the x part of our x-intercepts. And we just get x equals -1 or x equals 3. Okay, axis of symmetry. This is a new thing. Since we have a maximum value right here, we're going to have an axis of symmetry. If you draw a dashed line, cutting this in half, if you folded these together, it would be symmetrical. So it is going to be the h value. Okay, this point right here is very important. It is your maximum. the coordinate point for this would be 1, 1, 2, 3, 4. So that is your vertex, H, K. Notice our H was 1 and our K is 4. When it's in this vertex form, the H and the K represents either the maximum value or the minimum value of your graph. So in this case, the vertex is 1, 4. This is the highest point on the graph, so that is a maximum. A maximum would have a highest point, a minimum would have a lowest point. So the slope of this is m equals, well, if we do our triangle, we are going to draw a triangle. This line is increasing, so it's going to have a positive slope. Let's look at our rise, 1, 2. Let's look at our run, 1. So the slope of this half of the absolute value is positive 2 over 1. And this part, if we draw another triangle, it still rises 2 and runs 1, but it's decreasing. So it's going to be a negative 2 over 1. So we have two different slopes. To determine what our M is, we look to see if it's opening upwards or downwards. If it opens upwards, we take the positive slope. If it opens downwards, we take the negative slope. This was opening downwards, so we're going to choose this one, -2. That is our slope. That's what's in front of the equation in standard form. We will call that A. Okay, let's write the domain and the range in the different notations from before. So, set builder notation. For the domain, we write our squiggly line X such that, oh yes, and before we even get started with domain and range, let's go ahead and label our points, arrows, maxes, mins, and holes. So if we look at this, we have an arrow right here. Circle it. It's going left and down. So our coordinate would be -infinity, negative infinity. Okay, we have a maximum right here. It's already been labeled 1, 4. We have another arrow. It's going right and down. And that means it's positive infinity, negative infinity. So from here, our leftmost x value is negative infinity. Less than x, and then we look at the right x value. That's positive infinity. Positive infinity. Now, when we use set builder notation or inequality notation, we do not have to write those symbols. We just have to say all real numbers here. So go ahead, pause the video, try the rest of these. Okay, let's go ahead and do interval notation now. So the domain is still all real numbers, but we can put the negative infinity and positive infinity. So if we look back up here, our leftmost x value is negative infinity, and our rightmost x value is positive infinity. These are both arrows, so you're going to put open parentheses. So it will be parenthesis, negative infinity, comma, positive infinity. Infinity is those sideways 8 symbols. For the range, we still look at the lowest y to the highest y. So the lowest y is negative infinity. It's an arrow, so we're going to put a parenthesis. And we look at our highest y, which is 4. It's a point, so you will put a bracket. So we have from negative infinity, comma, 4, bracket. Okay, for inequality notation, you just take what you have for set builder notation and write it here, not taking out the braces and the such that symbols. So our domain is x is an element of all real numbers. And then for the range, you just write y is less than or equal to 4. Okay, let's talk about end behavior. So end behaviors is what is happening on the very left side and the very right side. Basically, these arrows that you named, negative infinity, positive infinity, negative infinity, that's your end behaviors. So, as x approaches negative infinity, we can write it in this notation. So this basically means as x is coming from the left side, y is going down. And as x is approaching positive infinity, y is also negative infinity. So as x is approaching from the right, y is going down. So basically the end behavior is from the left, y is going down, and from the right, y is also going down. That is our end behaviors. Increasing intervals is where the slope is increasing, it's where it's positive. It's going to be x values. So it's from negative infinity to our turning point, 1. So it will look like this. Our increasing interval is from negative infinity to 1. Our decreasing intervals is where we have a negative slope. So it'll be from the highest point all the way down. So from 1 to positive infinity. So we put it like this, 1, comma, infinity. And we put parentheses around these intervals. Okay, the last thing, find the absolute values of the following. The absolute value of 5 is just 5. The absolute value of negative 7 is a positive 7. Basically what we're doing is the output will always be positive, no matter if it's negative or positive to begin with. Now, if we have an expression with two terms in it that have different things. One of them does not have an I and the other one does. There's a special formula for this. Basically, we take the square root of the first number squared plus the second number squared. Three times 3 is 9, and 4 times 4 is 16. 9 plus 16 is 25, and the square root of 25 is 5. Let's go ahead and graph this last one. This right here is called an imaginary plane. You can really think of it as 3 being the x and -4 being the y. So our real part is 3. It's a positive 3, so we go over 3 to the right. It has a -4, so we're going to go down 4. 1, 2, 3, 4. And this is our coordinate point. Okay, go ahead and write a summary about this page.